All right, we're in section 8.2, testing the mean. So when sigma is known from a preliminary study, the observed test statistic is z equals x bar minus mu divided by sigma over the square root of n. We've seen that previously in the text. That's when it's known and you're using a z value. And if you're doing it without a graphing calculator, you're looking it up on a z table to find that area under the curve. Usually, however, sigma is not known. So in that case, we do the following. This goes back to chapter 6 information. If x has a normal distribution or is mound-shaped and symmetrical, then we can use any sample size. In other words, if the x distribution is normal, the x bar distribution is going to be normal. If we can assume the above, we need to have a sample size greater than or equal to 30, involving what we saw in chapter 6 called the central limit theorem, which can then be applied. And you can change, notice here we're doing a student's t-distribution. You can change a t-value equal, or you can get a t-value equal to x bar minus mu s over s divided by the square root of n, and use a t-table in the back. But again, we're going to do this on a graphing calculator. All right. And we're going to take a look at example 4 on the graphing calculator here in a little bit. So to test mu using the standard normal distribution, you're going to press stat, select test, and use option 1, which is a z-test. This is what we did in section 8.1. The value for the standard deviation is required, so we need to know sigma because you're going to have to enter that using the z-test. When we're testing mu using a student's t-distribution, we're going to press stat and select test, and then use option 2, which is t-test. Again, the value for the standard deviation is required. That's going to be s instead of sigma, right? Let me go on and show you the homework here at the bottom. I only picked out three homework problems to give you a good idea of what's going on. Page 464 to 465, numbers 21, 25, and 27. Remember, you can get the answers by clicking on the key and see if you got it right or not. Also, look over any other examples that you might want to before you get to the homework problems. Look over the other guided exercises and examples that they work out for you. So let me quit. I entered the data beforehand to make sure I was going to get this okay. So I'm going to clear that. Example 4, this is on page 403, by the way. The drug 6-MP is used to treat leukemia. The following data represent the remission times in weeks for a random sample of 21 patients using 6-MP. And so here's the raw data right here. 21 of them is the number of weeks, right? And so when we do stat calc, we'll see that one of the first options you get is that either you're going to use stats that are already given to you, which they are. Oh, that's sort of bad looking. It's only getting some of this. Let me see. Well, stop. All right. They give you the data right here. They tell you X bar is already calculated as 17.1. Sample standard deviation is approximately 10. Let X be a random variable representing the remission time in weeks for all the patients using 6-MP. All right, check it out. Assume the X distribution is mound-shaped and symmetric, right? So we can apply that central limit theorem rule, not central limit theorem, the other theorem. It's already mound shape. A previously used drug shipment had a mean remission time of mu equals 12.5 weeks. Do the data indicate that the mean remission time using the drug 6-MP is different either way? So it's a two-tell test from 12.5 weeks. We're using an alpha level of significance at 0.01. And so we're going to press stat. We're going to go to tests. We're going to do a t-test, which is option number 2. And again, for all of these options, you can either arrow down or up because there's a lot of them, or you can just type in this case, the number 2 and press enter, and it'll take you to this. All right, so here's if you're given the stats, you're going to click on stats. But if you were given all of this raw data here, you would go into stat edit, and then in list 1, enter this data and then do single var stats so you can find out what X bar and S are equal to, right? So let me go down here. So we've selected stats. The mean under the null hypothesis, mu sub 0 equals 12.5 to the 12.5 weeks, right up here, right? X bar is 17.1 weeks. Sample standard deviation is 10. Sample size was 21. Notice, do the data indicate the mean remission is different either way? So we know we're doing a two-tailed test. Let me go down here. So you want to make sure you select the not equal to mu sub 0. Then we'll go down to calculate. We'll press enter. All right, look at this p-value, 0.047. The p-value is greater than the alpha value, right? So let me go down here. Somewhere, there we go, conclusion. When the p-value is greater than alpha, we cannot reject the null hypothesis. There's not sufficient evidence to indicate that it is different either way. So that's how we would conclude our test. And the conclusion of the test, again, if you look at these examples or the answers as you go through the recommended homework problems, they'll make sure you know how to do the conclusion also. So in this case, it's not the number line. All of this stuff is if you're doing it by hand. We would just go with the p-value is greater than alpha. We cannot reject the null hypothesis based on this information given or based on the data given or based on the results. Here we go right here. We cannot say that the drug 6-MP provides a different average remission time than the previous drug. Get in touch if you have any questions.